Good morning, everyone. I am Michael ADESOKAN, IIT Nigeria. I am presenting on the quality evaluation of YAM, presenting on behalf of the IITA team. Outline standard operating procedures development for YAM quality evaluation for boiled YAM, pounded YAM, and also for textural profile analysis and sensory profile analysis of boiled and pounded YAM. Then the major results on YAM quality evaluation, cooking time and water absorption of the YAM genotypes, then the correlation between the instrumental and sensory texture profile of boiled and pounded YAM, then the conclusion and acknowledgement. A standard operating procedure was developed for sample preparations, which involve these materials: a knife and a ruler, a chopping board, and a sample punch. The sample punch is a stainless steel material fabricated to cut out a regular shape for each of the yam samples. The genetic materials involve 16 white yam provided by the Yam Improvement Program of IITA. For each genotype, 3 healthy tubers were selected and cut into proximal, middle, and axial ends using a knife, and the adapted stainless steel sample punch was used to cut out a regular shape for from each section of the yam, as we can see in step 8 and 9, and 6 pieces of cubed shaped yam were taken per genotype in step 10 for subsequent analysis. So for each genotype we have 6 cubed shaped yam which was taken on for the next step. The cooking time and water absorption involves these materials. We have a pot, a cooking pot, a thermometer, the weighing scale, then a strainer, stopwatch, measuring cylinder, and of course the gas burner. For the cooking experiment, the 6 keyboard yam were loaded onto the strainer and the initial weight was taken. The sample and the strainer were immersed in boiling water, and the water to weight ratio is about 8 to 1. And fork test was being conducted at 5 minute interval to be able to determine when the yam is cooked. The yam is cooked when the fork is able to penetrate to half of the of each of the keyboard. After the yam is cooked, they are immediately wrapped in aluminum foil to prevent heat and moisture loss and placed in a cooler for subsequent analysis. Few precautions involves having a representative of each of the yam tubers selected from each genotype. That was the essence of the sample punch, to take a uniform shape and a representative from the proximal, axial, and the middle end of each yam tuber. Softness is taken as an indication of cooking. So at 5 minute interval, fork was used to test if the yam yam is cooked. Then the SOP for textural profile analysis for boiled yam, the TAXT plus stable microsystem texture analyzer was used, and the 5 blade Ottawa cell was mounted on the texture analyzer. I have the text um, parameters provided as 2 per second pre-test speed. Test speed is about 1 per second, and a trigger force of 1 kilogram was used. Temperature of the test was taken at 45 degrees C. So the temperature of each of the keyboard was monitored using an infrared thermometer. So I have here the workflow for the instrumental texture analysis for the boiled yam. Then standard operating procedure was also developed for pounded yam using the same texture analyzer, but this time around a cylindrical compression probe of 30 in diameter was used for the double compression test for the pounded yam, and these are the test conditions. The general precautions for the instrumental textural profile analysis, it's important that the sample are analyzed at the same temperature between the instrumental and the sensory profile analysis. And of course, the trigger force of the compression probe must be carefully adjusted following the guidelines provided for the equipment, and replicate measurements were taken for both the boiled and pounded yam instrumental analysis. Also, for the sensory textural profile analysis of the boiled yam, 14 trained panelists evaluated the yam at the scale of 0 to 10, and the textural attributes were force, that is the hardness, ease to chew, chewness, and stickiness of the boiled yam. The serving temperature was also at 45 degrees C, and the 16 genotypes were subjected to sensory textural profile analysis. For pounded yam, the standard operating procedure developed by Bowen University was adopted, and the 16 yam genotypes were subjected to evaluation by 14 trained panelists on a scale of 0 to 10. The illustration of sample preparation and pounding of the yam is provided from step 1 to 7 using an electric pounding machine. The attributes evaluated were texture by hand, which is hardness, and moldability, adhesiveness, which is stickiness, and cohesiveness. The major results on the yam quality evaluation. Cooking time and water absorption are an important criteria for acceptability of boiled yam product. And the results showed that the average cooking time was about 10 minutes, and the water absorbed on the average was about 2 minutes. The maximum cooking time was at 18 minutes, while the maximum water absorbed was about 7%. A Pearson correlation was conducted to establish the relationship between sensory textural attributes and cooking time and water absorption of the boiled yam. And the results showed there was a significant positive correlation between chewness of the sensory textural profile analysis and the water absorption of the boiled yam. Also, cooking time shows negative correlation with the hardness and chewness from the sensory profile analysis, though the correlations were not significant. We also established the correlation between the instrumental textural attributes and cooking time and water absorption, and the result shows that there was significant positive correlation between chewness of the instrumental analysis and the cooking time of the boiled yam. A negative but not significant correlation exists between cooking time and hardness from the instrumental analysis. Water absorption also had a positive correlation with chewness from the instrument, but not significant. We establish relationship correlation between the instrumental analysis and sensory textural profile analysis for boiled yam, and results showed also that significant positive correlation exists between the hardness from the sensory profile and the instrumental textural profile analysis, and significant negative correlation also exists between the hardness of the instrumental analysis and the chewness of the sensory analysis. Hardness is the peak force during the exclusion test, while chewiness is measure of the energy required to masticate the boiled yam. Pearson's correlations between instrumental and sensory textural profile analysis for pounded yam was also carried out, and the result shows positive significant correlation between the modability from the sensory profile analysis and the cohesiveness from the instrumental analysis. Stickiness from the sensory profile analysis also had a negative correlation with cohesiveness from the instrumental analysis, though not significant correlation. The positive correlation between modability and cohesiveness was in agreement with the findings of Otegbayo et al. 2007. Conclusion. The positive significant correlation of instrumental and sensory hardness of boiled yam confirms that these textural attributes could be favorably determined using the instrumental method. Then chewness of boiled yam is one of the difficult textural attributes to measure, but its significant correlation with water absorption provides an alternative option for its determination. Cohesiveness equally is an important instrumental textural attribute for selection of mealy yam for boiled and pounded for pounded yam, and it has positive and significant correlation with modability in the sensory textural profile analysis, which is also an important information to the breeders and the food science. We wish to appreciate African Yam Project, RTB Foods, IITA, and the Bill and Melinda Gates Foundation for the support and the opportunity to make this presentation. Thank you.